Good morning. Welcome to Current SCHEM World. In this video, let us study Born-Haber cycle. How it is useful to calculate the lattice energy. This lattice energy cannot be obtained from experiment. So it is obtained by using Born-Haber cycle. Let us see with an example and how it is calculated, etc. Okay, let us see the Born-Haber cycle for the formation of sodium chloride, 1 mole of sodium chloride crystal. Let us consider the reaction between sodium in the solid state and chlorine in gaseous state to give 1 mole of sodium chloride crystal. Okay, this is the overall reaction, but this reaction takes place in several steps. We will see there are at least 5 steps involved to form this. Let us split the overall reaction into various steps. The first step is, in the first step, sodium is sublimed. Sodium undergoes sublimation to give sodium vapor. Okay, sodium in solid state is converted into sodium in gaseous state. This process is called sublimation process. So in the step 2, sodium atom in the gaseous state undergoes ionization to give Na plus gas. In step 3, chlorine gas undergoes dissociation to give chlorine atom in the gaseous state. Okay, this is the enthalpy of dissociation, this is enthalpy of sublimation, this is enthalpy of ionization or ionization potential. And in the fourth step, Cl accepts an electron to form Cl minus. This is electron affinity. Okay, how much energy is released when an electron is added to, when 1 mole of electron is added to 1 mole of chlorine atom in the gaseous state. The fifth step is lattice energy. See, this is lattice energy. The overall enthalpy of formation of this reaction, the overall enthalpy of formation of this reaction is equal to delta H, heat of formation of sodium chloride, 1 mole of sodium chloride equal to. And there are several steps. Okay, so it is equal to enthalpy of sublimation plus enthalpy of ionization or ionization potential, enthalpy of dissociation, okay, and then enthalpy of electron affinity and plus lattice energy. Okay, Born-Haber cycle is used to calculate the lattice energy of ionic compounds, especially ionic compounds which cannot be determined by experiment. Lattice energy cannot be measured by doing experiment. So it is indirectly calculated by Born-Haber cycle. Born-Haber cycle is based on HESS'S law of constant heat summation. So Born-Haber cycle applies HESS'S law to calculate the lattice energy of ionic compounds. Now let us define what is HESS'S law of heat of summation. It states that for a chemical reaction, let us consider carbon plus O2 gives CO2, combustion of carbon. Okay, this is the overall reaction and enthalpy of the reaction. Now this reaction can occur in 2 steps. Step 1, carbon monoxide is produced, delta H1. In step 2, carbon monoxide reacts with the oxygen to give carbon dioxide. The enthalpy for the second step is delta H2. So then the enthalpy change for the overall reaction is equal to the sum of enthalpy changes for the individual steps. So delta H equal to delta H1 plus delta H2. By applying HESS'S law, the overall change in enthalpy is determined by breaking the process into several individual steps. Okay, now let us calculate lattice energy of sodium chloride crystal with an example how to calculate the lattice energy by using the Born-Haber cycle. So this is the Born-Haber cycle for the formation of sodium chloride crystal. Okay, now there are several steps. The enthalpies, for example, the enthalpy of sublimation is known 108 kilojoule. The enthalpy of ionization potential, okay, it is an endothermic process. Heat is supplied to convert sodium solid into sodium vapor. Similarly, it is also ionization is endothermic process, so plus heat is supplied to remove an electron from the sodium atom. And dissociation energy for 1 mole, so 1 by 2, we need only one atom, so 1 by 2, 244 kilojoule. And electron affinity, this is exothermic process, because when an electron is added, it becomes octet configuration. Stable noble gas configuration. Therefore, electron energy is released during addition of electron. And the heat of formation for this reaction is known. It can be obtained by bomb calorimetry, etc. The heat of formation. So, except lattice energy, all the enthalpies of various steps are known. Let us now calculate by using the equation lattice energy. Let us rearrange the previous heat of formation equal to this equation, and now let us substitute in this the heat of formation minus 411, and then heat of sublimation here minus, so minus, and then ionization potential minus 496, and then heat of dissociation 1 by 2, so minus, and electron affinity 349, therefore plus, because here minus plus. So the lattice enthalpy for the formation of 1 mole of sodium chloride from 1 mole of gaseous components, Na plus in gaseous, 1 mole of Na plus in gaseous state, Cl minus, 1 mole of Cl minus in gaseous state, when they combine to form 1 mole of sodium chloride crystal, this is the amount of energy released. So it is an exothermic process. This process is an exothermic process. Thank you for watching. Please share and subscribe. Thank you again.